very quickly, this year's winter was marked by very strong zonal circulation, both in the troposphere and in the stratosphere. So the normalized Arctic Oscillation Index from the NOAA Climate Prediction Center showed monthly values greater than 2.4 standard deviations for each of January, February, and March. So the average of those 3 months ranked in the 70-year CPC record dating back to 1950 as first. So this was the highest recorded positive value for the Arctic Oscillation in the 70-year record. The stratospheric circulation was such that there was an ozone depletion region, in fact, in the late winter, which is shown here. So recent studies have looked at delayed follow-on season conditions for sea ice in comparison to the winter circulation. And they show a tendency for low ice for the positive value of the Arctic Oscillation in the Kara and Barents Seas. So these studies have looked at both the strong stratospheric circulation and also they're consistent with the Arctic Oscillation Index. Next slide. So slide 2 shows the zonal flow restricted the propagation of cold Siberian air, and there was an early loss in snow cover over Eurasia. So the Siberian cold pool didn't really act to cool off much of the hemisphere as it normally does. It was kind of restricted by this more zonal flow of the associated with the Arctic Oscillation. Next slide. Thank you. So slide 3 shows a heat wave event that occurred in mid-June over Siberia. So we have a snapshot theme on our GMAO homepage that you might want to look at. It also has an animation. So temperatures reached 38 Celsius, 100 degrees Fahrenheit at 67 degrees north, an all-time record. An animation shows that there was a mild response of the sea ice concurrent with this warming event, either from the temperatures, the nearby temperatures, or perhaps from the anticyclonic circulation that spread offshore. The extent time series shows a rapid decrease in these areas over the following month. That's either a response to this warm event or perhaps from something else. Next slide, please. And there continue to be warm air intrusions over the Arctic throughout the summer. So the figure on the left shows one of these events extending over the Barents over towards northern Greenland. Mosaic, incidentally, after reaching Fram Strait, went back towards the North Pole very quickly over surprisingly loose sea ice cover. So it's not clear if this late July event led to those loose ice cover over this area of the Arctic, but certainly the Mosaic expedition found these very low fraction ice conditions. So the preliminary National Snow and Ice Data Center extent for August 26th, yesterday, is the second lowest for the date, and it's about 500,000 square kilometers above the 2012 value. So that's just a very quick setting for the Arctic conditions leading into this summer. So our first presentation then today will be from Jinlun Zhang. Jinlun Zhang is a senior principal oceanographer at the Applied Physics Laboratory at the University of Washington, and he'll be talking about the biomass forecasts.
Thanks, Richard. Hi, everyone. Okay.
You can see your slides.
Yeah. Well, every year since 2008, we have been participating in the September Arctic Sea Ice Outlook using what we call biomass. So here I'd like to briefly report what we have done for this year's Outlook. This work is done in collaboration with ARCUS. Next slide, please. First of all, I'd like to give a little bit of information about biomass. It's a coupled CIS Ocean Model. The CIS model is a 12-category subgrid scale eye thickness, entropy, and the flow size distribution model, covering eye thickness up to 28 meters and the flow size up to about 3 kilometers. A teardrop viscous plastic CIS rheology is used, which allows by actual tensile stress as seen often in lab tests. The ocean model is the POP ocean model or parallel ocean model, a parallel ocean program developed at the Las Palmas National Laboratory. HIMARS handcast is forced by the next slide, please. Now, HIMARS handcast is forced by the NSEP Climate Forecast System, or CFS, reanalysis atmospheric forcing over the period from 1979 to the present. The CFS reanalysis product is one of the 3 best performers among 7 reanalysis products when compared to a range of independent measurements in the Arctic, including air temperature, precipitation, and wind speed based on Lindsay et al. 2014. Now, handcast output is used to initialize HIMARS ensemble seasonal forecast to improve the initialized ocean conditions for forecast. Daily satellite sea ice concentration and sea surface temperature are simulated in HIMARS handcast over the period from 1979 onward. Also, Cryosat 2 sea ice thickness is simulated wherever available over the period from November 2010 to April 2020. Next slide, please. Now, HIMARS ensemble seasonal forecast is forced by CFS ensemble forecast atmospheric forcing. The CFS forecast ranges from hours to months. There are a total of 16 CFS ensemble forecast runs every day, including 4 forecast runs that go out to 9 months. These ensemble runs all create 6 hourly forecast atmospheric data that are widely accessible online in real time. So ideal for forcing HIMARS ensemble seasonal forecast. Now, atmospheric forcing from the 4 9 months CFS forecast runs is used to drive 4 ensemble members of HIMARS sea ice forecast with a forecast range of 7 months. Next slide, please. Now, what is the effect of assimilating Cryosat 2 sea ice thickness data? This slide shows a comparison of sea ice thickness between ice bridge observations and HIMARS results with and without assimilating Cryosat 2 data over the period of 2012 through 2018. The left panels are scatter plots with some statistics, and the right panels show model observation differences of the locations of individual data points. Now, without assimilating Cryosat 2 data, the model has more noticeable spatial bias. Ice is a little bit too thick in the Beaufort Sea and a little bit too thin near the Fram Strait when compared to ice bridge data. Now, when assimilating Cryosat 2 data, the spatial bias is reduced, and the overall model mean bias and the RMS error are reduced, while a model observation correlation is increased. So generally speaking, assimilating Cryosat 2 data helps improve the sea ice initial conditions for forecast. Okay, so what is happening in the Arctic these days? Richard has shown some nice slides here. Now, so here, before showing some prediction results, it is useful to examine satellite observed evolution of Arctic sea ice extent in 2020. Compared to other years, next slide, please. Yeah, so here, So this slide essentially shows Arctic sea ice evolution, Arctic sea ice extent evolution this year. So we want to show this one because it's useful to explain our prediction results. Now, compared to other years, sea ice extent this year stays generally closer to 2012 when the record low September sea ice extent was reported, suggesting that 2020 is also a low ice year in summer. However, there are some interesting differences between 2012 and 2020. On June 1st, as we can see, ice extent was lower this year than 2012. On July 1st, we can see that the ice extent this year was close to 2012, but with a steeper reduction. On August 1st, ice extent this year was again lower than 2012, but with a slower reduction, as you can see. So the question is, do this observed change in Arctic sea ice evolution have anything to do with our sea ice prediction? Next slide, please. Well, actually, the prediction results and the observed sea ice changes are linked together because closely somehow. We conducted 3 ensemble predictions of September Arctic sea ice extent this year, starting on June 1st, July 1st, and August 1st. The prediction extent on June 1st and July 1st are all lower than 3.61 million square kilometers, which is the lowest September ice extent of the satellite era observed in September 2012. This is linked to the fact that the ice extent this year is lower on June 1st or decreased faster on July 1st when compared to 2012. When we first saw the results, we were like, wow, are we going to have a new record now this year? However, as shown in satellite observations, the reduction in ice extent was slowing down on August 1st. So as a result, the prediction of September ice extent on August 2012, on August 1st, it's increased to 3.8 million square kilometers, which is higher than the previous record low. So this means that September 2020 is unlikely to set a new record low ice extent based on this August 1st IMS forecast. It also shows that the prediction results really depend on the initial ice conditions. Next slide, please. Now this slide shows IMS predicted September 2020 sea ice thickness field and the edge location together with ensemble standard deviation. Results are from predictions on June 1st, July 1st, and August 1st, as shown before. The black line is predicted ice edge for September this year, and the white line is satellite observed ice edge for September 2019. So it's last year stuff, last year ice edge. The ensemble standard deviation gives a measure of prediction uncertainty. The predicted ice edge is quite different among these predictions. The predictions on June 1st and July 1st are likely to have exaggerated ice reductions, likely because of the initial conditions. Now, because of the reduced forecast range, the prediction on August 1st will be closer to reality. It suggests that the September ice extent this year is very likely lower than last year. Next slide, please. Okay, so why ice extent in September 2020 is likely higher than September 2012? To answer this question, we'd better take a look at ice handcast, which is often not too far away from reality. Here is IMS handcast of the sea ice thickness on August 15, 2020. The black line is hindcast of ice edge on that day, and the white line is satellite observed ice edge on August 15, 2012. As we can see, 2020 has a lot more ice in the Balfour Sea than 2012. Ice there is quite thick and therefore unlikely melt away going into September. This is probably the main reason that we are not going to see a new record low this year. But Richard just showed a big hole in the Balfour Sea where there is no ice. So in the recent few days, there was something going on in the Balfour Sea that created a big hole in the Balfour Sea. So we'll see what the reality is in September, which might depend on just weather conditions. Next slide, please. Here is the summary. Prediction results closely depend on initial conditions, initial sea ice conditions, which is not really surprising. Arctic sea ice extent in September 2020 is very likely lower than September 2019, but it is unlikely to reach a new record low based on the latest IMS forecast. Now, Arctic sea ice extent in September 2020 is likely higher than September 2012 because of more ice in the Balfour Sea, as shown in the hindcast simulation, well, which remains to be seen if that's the case. Finally, some questions. Is the 2020 ice buildup in the Balfour Sea somewhat unusual in recent years? The buildup before the summer came. If so, what causes it? Would be interesting to examine that at some point. Thank you.
Thanks very much, Jinlun. I think we have some time for some questions here.
Okay.
Does anyone have any questions?
Hi, this is Walt Meyer. Nice presentation, Jinlun and Richard before. Really great to, great summaries. Jinlun, just you talked about the Beaufort Sea there. One of the things we looked at with ice age, it looks like there's quite a bit of older ice that's been transported in that area. Does that make sense as a likely cause for that ice hanging around there longer?
I think that makes sense. I think that somehow, in winter or springtime, then something happened that there was some kind of ice buildup in the Beaufort Sea. So that the ice thickness there, it seems like corresponding to what you see in terms of ice age.
Thanks.
Yeah.
Jinlun, what is meant by, for the sea ice thickness, what is meant by assimilation? Do you use, is this part of the standard biomass assimilation scheme, or do you do something different for the thickness?
Well, the thickness, the initial conditions were in the hindcast biomass assimilates chloride to ice thickness. So essentially the biomass ice thickness is pretty much altered by chloride to data. Is that your question?
So do you insert the cryosat to ice thickness, or do you do something else to incorporate it into the initial condition?
Oh, so whenever we got the cryosat to data, so we would just assimilate it using the optimal interpolation technique.
Optimal interpolation, okay. Yeah.
So Jinlun, this is Wisław Maslowski here. Could you comment on why you're stopping after 4 months instead of running it for full 6-7 months of the ANSYP forecast?
Well, the reason is that by the time we get into like get into the end of 4 months, it's the prediction uncertainty would be very, very high. The prediction results are not really reliable because the memory of ice it's long gone. So this is why we just stop at the end of 4 months.
Thank you.
Okay, with that, let's go on to our next speaker. Rick Allard is an oceanographer at the Naval Research Laboratory at Stennis Space Center in Bay St. Louis, Mississippi. He will talk about the Navy Earth System Prediction Capability System.
Thanks, Richard. Hopefully everybody can hear me okay. So I'll be discussing the Navy's Earth System Prediction Capability. This is a joint effort between our Ocean Sciences Division and the Marine Meteorology Division in Monterey. I've given a few names, but there's many more people involved with this effort that I did not put on this slide. So next slide, please. So there's a growing importance in seasonalized prediction, increasing interest by the operational Navy to provide seasonal forecasts of ice conditions in polar regions to support navigation. The experimental Navy ESPC has been providing 45-day ice forecasts to the National Ice Center since November of 2017 to support ICEX. The McMurdo resupply in the Ross Sea, typically that's January and February of every year, and more recently, which is ongoing Operation Nanook, which is in Baffin Bay. New techniques and additional satellite-derived ice freeboard data present opportunities for improving predictive skill with coupled modeling systems. Next slide, please. So this is just a schematic of the ESPC system. I'll try to avoid the acronyms, but I might touch on a few, but it's got the Navy's NavGem Global Atmospheric Model, HICOM is the Ocean Model, and SICE-4 is what's presently used in Navy ESPC. Couple forecasts go from the bottom of the ocean to the top of the atmosphere with extended forecast lead times out to subseasonal timescales of 45 days. Next slide. This just gives a little more detail of the fields that are passed between the various models. So if I were to give an example of the atmospheric model on the left, NavGem, the arrow points down, shows you what is shared. It goes to the mediator or coupler. So your 10-meter winds, your 2-meter temperature, specific humidity, your precip, and the mean sea level pressure. And then those are fed to the coupler, and then HICOM will input the atmospheric data from the model as well as your ice information. And likewise on the SICE model, it shows you what is transferred, and the data is exchanged on an hourly basis. Next slide, please. So this shows you what our plans are. So I'm talking today about the probabilistic or long-term system. So it has 15 ensemble members. The atmospheric model has a resolution of 37 kilometers, 60 vertical levels. The ocean is 9 kilometers with 41 layers, same with SICE. So for the pole, the resolution is 3.5 kilometers for the ice and ocean model. The system should be declared operational by next Monday. It's undergoing op test by Fleet Numerical right now. And the deterministic system, which I'm not really talking about today, that will go from 0 to 16 days. That'll be run daily. And they're looking at late 20, early 21. And then the next version of ESPC, version 2, which has an FY22 time horizon, they're looking at seasonal 90-day ensemble forecasts. Of course, you need computational cycles to do that. So I'm not 100% certain that that will happen, but they're certainly investigating that. There's joint effort between the two divisions on coupled data simulation. We're adding WaveWatch 3, so you get interactive ocean surface waves. And then lastly, we're presently adding SICE 6, which includes landfast ice. So next slide, please. I think this is somewhat redundant, so I won't read the top part. But as Jinlun had said, you know, we're participants in the CIS Outlook. We run our 15 ensemble members. The first is initialized on May 1st, and it's run for 5 months through the end of September. And then the following reports initialized 1 June and 1 July. The report has a month after the submission, so we're waiting now on the August report, which I assume will be released any day now. So next slide. So this comes from the July report. So this is when we initialized the model on 1 June. And as you can see, we had the highest prediction. Someone has to be the highest or lowest. And in this case, it was the Navy ESPC at 5.2. Obviously, this is a busted forecast. On the right, I'm showing you our stats. And you can see with the May 1st initialization, we had 6.1. And then this one was 5.2, and then the August 1st is 4.2. So obviously the 4.2 is more realistic, but we need to further investigate, you know, why aren't we doing a better job for those other forecasts. And as of, I think Monday or Tuesday, it was 4.59. I think I checked this morning, it's 4.5. So obviously it's headed downward. You've got at least a couple more weeks, and it will rival 2012, but as Jinlun had said, it probably won't be quite that low.
I think you might be muted.
I'm sorry, I was saying next slide, sorry about that. Okay, so this is from our initialization of 1 July, and this would appear, at least the graphic on the left will appear in the August report. So you can see on the left, those are our September median extents for ensemble members 1 through 15, and then there's a control shown on the upper left. What I'm showing you on the right is what the ensemble mean looks like for September, and it's going to be the darker, thicker red line. And then what's overlaid in blue is from Snow and Ice Data Center. That's the extent as of 24 August. And there's still a couple of weeks to go where that blue line most likely will get more poleward. But you can see off the coast of Alaska, you know, there's pretty decent agreement. But further north, yeah, we're not capturing that that sea ice extent minimum. But overall, reasonable. But again, this is initialized on 1 July, and the one that we initialized on 1 May certainly had a sea ice extent further to the south. Okay, next slide, please. So as Jinlun had said, where the PMS model assimilates Cryosat-2 data, we presently are not assimilating any ice thickness or ice freeboard data, but we have been doing studies. So this is a paper that recently went online for Annals of Glaciology. So we ran a series of twin experiments from 2018. We initialized 1 May, and the control run had no Cryosat-2 initialization, and then the CS2 Cryosat-2 run did. And I guess the first take-home point here on the left, we're off the coast of Alaska. You can see an improved sea ice minimum. That's the blue line, whereas the red line is the control run. In the upper middle, you can see the extent over time. And on the right, when we initialize with Cryosat-2, we get a more realistic sea ice extent. Certainly looking at the ensemble mean, we're still too early. I think we hit our minimum around September 6th. And I think in 2018, it had 2 minimum, and one of them was like on the 21st. So that's something that we still are investigating. And we compared against the 3 moorings that WHOI deploys every year. So you're looking at ice thickness, we compare to the ice draft. So I'm in the bottom of the middle. And so you can see on the far left where mooring A is. And so you're looking at the control run, which is the red line, and overall the ice is thicker. The black line is the observed ice thickness, and we performed, I believe, a 5-day moving average. And then the blue line is with the cryosat-2 initialization. You can see that it certainly does better, especially here, but we don't get ice free. Whereas I think in late August, it was ice free. The ensemble system did not capture that. And what I didn't say, this was a time lagged ensemble system with 10 ensemble members. And lastly, on the right, that's just taken from the HICOM model, and we just did a difference. I think it's a September mean difference of sea surface temperature between the cryosat-2 run and the control run. And you can see the red areas are where you have open water and obviously warmer sea surface temperature. So anyway, this shows some promise. And probably mention on the next slide, but we are testing one of our other systems, which is called GOFS 3.5 with a long track cryosat-2 ice thickness. And that's showing a lot of promise. So that's something that we anticipate will go into operations at some point in the future. Next slide, please. So summary and future plans. The Navy ESPC 15-member ensemble system is scheduled to become operational as official next Monday. The next version of ESPC version 2, it will use Size 6, which has landfast ice coupled to WaveWatch 3. There's some work that the community has added to WaveWatch 3. There's also SWAN, some of those ice source terms, some of that's based on the work that ONR funded. The Sea State GRI said testing's underway to simulate cryosat-2. We're investigating the use of cryosat-2 and SMOS, as well as ICESat-2 to improve initialization for seasonal prediction. As we know, ICESat-2 is not presently available in real time, but we'll keep pushing our NASA colleagues to see if they can bring that latency down to ideally, 3 days would work great. And supposed to ask a question. So what is your prediction for September Pan-Arctic minimum extent? We know it's going to be lower than 4.5. Whether or not it gets below 4, we will see. And I think that's all I had. Sorry if I went a little fast. And I'll turn it back to Richard.
Thanks very much, Rick. That's very impressive. The resolution and number of ensemble members is very impressive. Do you think the higher, what was the resolution of your previous system?
It's essentially, it's the same resolution. So our GOFS 3.1, it's a 1/12 degree ocean, 1/12 degree ice. The atmospheric model, I believe, has a higher resolution here. And the folks in Monterey, obviously, that's their strength. They've been doing a lot of work with the atmospheric model. Yeah, so I mean, as I said, we're disappointed in our early season. I think last year when we had the time lagged ensemble, I shouldn't say this, but we were second lowest, and we were the lowest was a 5th grade class. So when you're being beaten by a 5th grade class, you need to roll up your sleeves a little bit more. Not that they can't do good work, right?
Great. And for the cryosat-2 data, do you use data directly from Alfred Wegener? Is that where you access the data, or?
For the paper, Nathan provided the data.
Oh, so that's from the data.
But yeah, for the cryosat-2 out, the SMOS, that would be from Ali. And of course, for our studies, we're initializing in the fall and we're running it out beyond that. And so certainly for ICS Outlook, you can run, a long-term forecast, and then you just want to use those forecast fields for your ice thickness when you do your initialization for the seasonal runs. And that's what we're not doing right now, and we believe that will improve. But perhaps next year that'll be something that we can test.
Okay. Are there any questions? And if not, I'll ask the Sea Ice co-leads if they have any questions.
Yeah, this is Janet. I had, Rick, thank you for bringing up the ISAT-2 forward-looking products. And you mentioned a latency of 3 days. And I was wondering, given that I guess I was wondering, when is the last point that you used the Cryosat-2 data? And wouldn't ISAT-2 give you something, if it wasn't 3 days, maybe 30 days, would that be useful to you as well?
Yeah, it could be useful. I think right now, and maybe Torsten or somebody can correct me, anybody familiar with the Cryosat-2, I'm sorry, ISAT-2, I want to say it's 45-day latency. If there was a 30-day latency product, we certainly could use it. So let's think about like the May 1st initialization. You know, we would need something as of 1 April or before that, you know, and you'd have to just run your forecast system far enough into the future and then capture those fields to initialize your model. Does that make sense?
Yeah, thanks.
Sure.
Nathan,
Yeah, and
yeah.
thanks. Yeah, I was going to say I'd like to comment on the latency. So on ISAT-2, we're working towards a 45-day latency. That would be for final products. We're not there in terms of a regular cadence for that, and so that really would be like a 45-day latency, just because we have limitations on our processing side and how things are done there. So, but we are looking into using what are called rapid products, and so those are available maybe 2 to 3 days later. They are of lower quality, at least for the elevation, and there's a bit more noise. But yeah, potentially that could be something that could be done in the future. We have a proposal in to get that spun up. It'd be a bit of work, but and then also to do some error analysis. You know, what additional error is present in the data by using those rapid products. But yeah, I think in the near future we will certainly take a look at providing that data.
That'd be great.
Yeah, this is Torsten. Maybe let me add something here. We at NASA have what is called the Satellite Needs Working Group. And this is open to other agencies to make requests and suggestions. And in the last open call for data needs, there was a request, maybe by Rick's group, I don't remember, 2 years ago, to actually develop a low latency data product. And after this was officially submitted 2 years ago, as Nathan said, the ISAT-2 project office submitted a proposal to us, NASA, for the development of a low latency data product. And that the funds for this proposal will be in the next president's budget. So hopefully that will get approved, and then we NASA will, go full steam ahead. Mostly Nathan and his group go full steam ahead to develop a low latency product.
Oh, that'd be great too.
That sounds great, Torsten. Thanks. Okay, thanks very much, Rick. With the time remaining, the co-leads thought that maybe we could give a chance for other dynamical modeling groups to give a short 1-minute discussion on their forecast if they would like to, and perhaps ask a question or add to the discussion that we're having here. Are there any dynamical modeling groups on the line that would like to do that?
So I can speak on behalf of the Regional Arctic System Modeling. We are contributing. I don't know if anybody else is there, but from our group, there's Mark Seefeld, Young-Ju Lee, and Xingrang Wu, who are contributing to the ICS Outlook forecast. We're using fully coupled regional Arctic system model, which consists of the atmosphere, ocean, sea ice, land hydrology, and the river routing scheme. And we're basically using this regional model for dynamic downscaling of the NCEP hindcast and the forecast from the global atmospheric model output. Our forecast for September mean minimum of 2020 initialized on June was 438 million square kilometers. Initialized on July 1 was 416 million square kilometers, and initialized on the August 1, we went down to 4.13 million square kilometers. So there's not much change, 0.2 million square kilometer change in the forecast between June initialized and August initialized. The important aspect is that we are not doing any data assimilation for our initial conditions. It's derived from a multi-decadal hindcast. And we're basically focusing on having improved model physics to get us initial conditions without data assimilation as realistic as possible. We're running order of 30 ensemble member each time for every month initialized 6 months forward. And we don't see much of the decline in the model skill when you compare the forecast in the past over a 6 months period, with an exception of the shoulder season where changes in the ice melt or ice freeze up during the spring and fall can contribute to seasonally increased model error. But looking at the 6 months forecast, actually, we're beating the persistence, and we're on par or sometimes better than the climatology. I'll stop here.
Thanks very much, Wisław. I think I can go next. The NASA GMAO produces a subseasonal and seasonal forecast, which is displayed on our GMAO homepage. Historically, we've had difficulty maintaining sea ice in the summertime in the Arctic with our standard system. So we've been doing these one-off experiments of inserting Cryosat-2 sea ice. We would run our ocean data assimilation system, which is weakly coupled with the atmosphere, and insert the Cryosat-2 sea ice and run that system for a period, for as long as we can afford, like 5 months or something like that, and then initialize the forecast from there. We're using a prototype system. We were using a prototype system this year. We had some difficulty tuning up the sea ice albedo, and we got a large value, 4.7. So I think we still have some work to do. Anyone else?
So I'll just add, because Youngju reminded me, he put on the chat that Rossum has an official publicly open website with those 6 months forecasts, if anybody is interested. It's on the chat.
Okay, yeah, I see that, thanks. Okay. Anyone else? I guess my reaction to this year's conditions and this year's summer conditions are that this is going to be a great year for retrospective analysis, since we had such a strong signal of the Arctic oscillation in the wintertime. It bears some examination of how our system responds to these teleconnection patterns, and perhaps or doesn't respond. I looked for a warming signal over Eurasia in our individual ensemble members, and I didn't really see the kind of signal that is suggested by the prior publications. So I think that's going to be something to look at in the future as we look back on this year. Okay, I think that's about it. And so I think I'll hand it to Janet, if you have any last comments.
I'm sorry, it took me that long to take myself off of mute. Thank you to everybody. I found that really interesting, and I echo Richard's sentiment about this being a really interesting year. And I know that these signals are overlaid on the minimum each year, but I think this year gives us kind of that pendulum effect that allows us to really kind of tease out what these external influences are and how it's so challenging to get these predictions on such a long time scale correct. So I really appreciate the CI's team appreciates the opportunity to hear about this from a more dynamical modeling perspective. So thank you to everybody. And if any of my co-leads want to add anything, I'll give you a minute to do that as well. But thanks, everybody.
Thanks, Janet. Anything else from the modeling subteam co-leads? Wilbert?
No, this was a very interesting meeting. Thanks to you all for the very interesting presentations, and to Richard for organizing this and putting this all together in collaboration with the CS collaboration team. So thank you.
All right. I think for next month, the modeling subteam is currently open. We're going to have a meeting on the CIS model intercomparison project, a recap of that. But I think we've been asked to delay that until October. And I believe there's going to be several meetings on Mosaic throughout IARPC in October. And I believe the CIS collaboration team is also having meetings on Mosaic in October as well. So we look forward to seeing you then. And I'd like to thank again the speakers, Jinlun Zhang and Rick Allard, for participating today. Thanks very much.
Thanks.
Yeah, my pleasure. Thank you.
Bye-bye.
Okay, we'll see you later then. Bye-bye.
Thanks.